All right, so example number one. Again, we have to know our properties of exponents. So how are we going to handle number one? Well, we're just multiplying two algebraic expressions together. So how are we going to handle that? Well, the first thing I recommend you do is look at what is called the numerical coefficient of each expression. All right, here we have a 4 and a 2. So the very first thing I'm going to do is multiply those two numbers together and get 8. The next thing I'm going to do is look for like bases. So in this case, do you see we have two pairs of like bases here? We have the x's, and we also have the y's. All right, so what do? When we multiply like bases. When we multiply like bases, we add the exponents. So you get x to the negative 1. Why? Because 2 plus a negative 3 is negative 1. So x to the negative 1. Moving on, the final pair of like bases here would be the y's. So again, add exponents. Y to the negative 1. Okay, you're not finished yet. Why? Because your answer should only contain positive exponents. Understand that. Okay, make sure you are reading the directions carefully. So we're not finished here. So how do we rewrite this? Well, the 8 is going to stay exactly the same. And what I mean by that is it's going to stay in the numerator position. All right? This is just 8 to the understood 1. It's not going to change. This negative 1 is only referring to the base that immediately precedes it. So this negative 1 is only being applied to the x. So we know by definition, x to the negative 1 is the same as 1 over x. In other words, this x was in the numerator position, but the negative 1 is going to move it into the denominator position. Same with the y. Y to the negative 1, same as 1 over y. And so you get 8 all over xy. Example number 2. In this case, we have, again, a couple of algebraic terms here being raised to a couple different exponents. So because that's the case, even though these two expressions are being multiplied together, we have to follow PEMDAS still. We have to follow order of operations, which means we have to work with the exponential portion of this first. All right, so let's see what happens when we have this quantity cubed. Well, again, like I was stating, what it really means is, let me show you what it really means. I'm going to go ahead and make this 3 to the first. It's the same as 3. I'm going to make this 2 to the first. Again, it's the same here as 2. When you have a product to a power, what you're really doing, in essence, is almost like you're distributing the exponent through every one of these other exponents inside of the parentheses. All right, so you're just going to be multiplying this 3 through the 1 and through the negative 2. So what do we get? We get 3 cubed. Then we get x to the power of a power you multiply. So negative 6. And same thing with the next expression. So really, it's 5 times 1 and then 5 times 2. So 2 to the 1 times 5, that's 2 to the 5th. And then x to the 2 times 5, that's 10. All right? That's what you do when you have a product to a power. You're multiplying the two powers or exponents together. Okay? So at this point, we should be able to understand, I hope, that 3 cubed is what? Well, you can use your calculator if you need to. That's 27. I'm going to go ahead and bring down the x to the negative 6. And then 2 to the 5th, let's see, what is that? 2, 4, 8, 16, and all 5 would be what? 32, right? 2, 4, 8, 16, 32. Again, you can use a calculator if you so desire. And then bring down the x to the 10th. All right, we're not finished yet. You still have a couple of numbers to multiply together. So again, take out your calculator, see what you get. What's 27 times 32? I believe it's 864. And then we are now multiplying like bases. Multiplying like bases, so x is like base. Add exponents. When you multiply like bases, you add the exponents. Negative 6 plus 10 is 4. Finished with example number 2. All right, rock and roll. Let's keep going. We're going to get a little more challenging now. Again, if you know the properties of exponents, and you know order of operations, you should be all set with this material. But this can get pretty, involved pretty quick. But as long as you're following the properties and your order of operations, you should be okay. All right? All right, with that being said, there will be more than one way to handle these types of problems. All right? It doesn't matter to me what route you take, just as long as the route you take is, of course, correct. All right, so number 3. Well, I'm going to do a couple things first here with number 3. So I'm going to look at the numerator, and that's all I'm going to focus on, just the numerator right now, okay? So I'm going to do 5 times 3, that's 15. And then I'm going to do the multiplication of x squared times x to the negative 2. Well, what do you get here? When you add like bases, when you multiply like bases, you add the exponents. All right, so you actually get x to the 0, which we all know is what? Just the x to the 0 is the same as 1. Good. All right, now in this denominator position, I'm going to go ahead and change one thing. Note we have a product occurring here, but we have an exponent occurring here. So we have to do this first. You have to do exponents before you do multiplication. So with that being said, I'm going to bring down the 4x minus 1. And I'm going to go ahead and look at this as what? A power of a power situation. When you have the situation, you multiply the exponents together, giving you x to the negative 6th. All right. So the next thing I'm going to do with this one is, again, I'm going to review that this just x to the 0 becomes a 1. So in the numerator, you have 15 times 1 understood. 15 times 1 understood is still 15. And now in the numerator position, 4 times an understood 1 is still a 4. And again, we are multiplying like bases together. When you multiply like bases, you add the exponents. Negative 1 plus negative 6 is negative 7. Are we finished yet? No. We are not finished because you have a negative exponent involved here. You are not allowed to have any negative exponents in your final result. So this has to change right there. Just this. This negative 7 only applies to the base x immediately preceding it. So final answer would be 15 what? 15x to the positive 7. That's what a negative exponent does to the base. It moves it from either the denominator to the numerator or from the numerator to the denominator. All right, final answer, 15x to the 7th over 4. Okay, let's take a look at number 4. Number 4, you have a quotient to an exponent. All right, so you could handle this again. You could start these off in different ways. You could distribute this negative 3 through every single exponent. Multiply every single exponent by this negative 3. You're allowed to do that. However, I'm not going to do that. I'm going to recognize that I have like bases occurring inside of these parentheses. So because I recognize that, I'm going to go ahead and simplify what I can inside of the parentheses first, before I even worry about this negative 3 that's in the exponent position. Because again, you have grouping symbols here. You can do grouping symbols, right? You're supposed to do those first. You look at PEMDAS. All right, so here's what I'm talking about. Let's go ahead and do this and keep the negative 3 the same. All right, let's take it step by step. Okay, so the 2 is not raised to anything inside the parentheses. I can't reduce it with the 3. They're both prime. So I'm going to go ahead and just write down these two numerical coefficients. So 2/3. The next thing I'm going to do is look at these bases that I'm dividing. All right, I'm dividing the x's. So really, when you divide like bases, you're going to subtract the exponents. But here's how I like to do this. Okay, I like to identify that these two are, of course, the same. Then I'm going to ask myself a couple questions. Okay, here are the two questions. Number 1, which exponent is greater? Is it this one that's understood to be a 1, or is it this one that's a negative 2? Well, of course, it's 1, right? 1 is greater than negative 2. So you identify that. So that's the first question. Wherever the larger exponent occurs, that's where your base is going to remain. So I know that I'm going to have an x, at least initially, looking at the interior portion of this, in the denominator. That's where it's going to stay, all right? But now I'm not finished with this yet. I got to ask myself a second question. And the second question is, all right, well, how much greater? How much greater is 1 as compared to negative 2? How much greater is 1 than negative 2? It's 3 greater, so this becomes x cubed. And that's it. Let's do the same thing with the y's. Let's see if this works. So really you have y cubed on top and y to the understood first on the bottom. Well, which exponent is greater with respect to the y basis? Well, if 3 is, of course, greater than 1, right? So because this is occurring where? On top. In the numerator, you know there's going to be a y remaining on top, at least at this point in the process, right? And the second question is, all right, well, how much greater is 3 than 1? It's 2 greater. So now you have y squared. That's how I handle the properties of exponents with respect to dividing of like bases, okay? At this point, I tell you what, I'm just going to do one thing at this point. What could I do? What one thing could I do at this point if this entire quotient is being raised to a negative 3? Well, here's what I could do. I could rewrite this as 3x cubed all over 2y squared to the what? To the positive 3. That's what a negative exponent does to the base. It inverts it. So everything that was on top is now on the bottom. Everything that was on the bottom is now on the top. Now what are we going to do? Well, in essence, we're going to be distributing this exponent through every single part that makes up this quotient. So understand, this is really 3 to the first. This is really 2 to the first. Okay? So what do we get? We get 3 cubed. X to the power of a power, we multiply x to the 9th. Then we get 3 times 1, right? 3 times 1, 2 cubed. Then we get y squared cubed. That's 2 times 3y to the 6th power. And then we simplify this thing completely. And we get what? We get 27 x to the 9th. And then 2 cubed is 8. And you get that times y to the 6th in the denominator. And you're all set. Isn't this fun? Let's do a couple more and we'll be finished with section 1.5.